5.8, we talked about fractional coefficients, where we have to just get rid of those fractions, make it easier on us. And then we kind of got into ones that had fractions with variables in the denominator. Remember the math club one? There was a fraction in the denominator. And then you guys went on to do on your own the one with the mixing problem, the chemistry problem, with the acid and base solution. Okay? If you struggle with that, if you feel like you need a review on that, please see me at some point. Okay? That's a problem that's probably going to be on your test. That kind of a problem, the mixing one or the math one from yesterday. So if you struggle with that, come see me. I'm happy to go over it with you. So in this section, we're going to look at fractional equations. There's two methods. Okay, the first method is the one we did yesterday. Just find the LCD. The second method is the one we did yesterday. Find the LCD and then simply just multiply everything in the equation by the LCD. Personally, I think this is the easiest way to do it. The first method is the other one that I talked about yesterday. Cancel all the denominators by making the LCD the same for everything and solve what's left. Okay, I'm going to probably go to method 2. So let's take a look at this. How can I find an LCD? I don't know what's going on. I don't have any factors in my denominator. So I start by factoring right away. So all I did was factor the middle term. That's it. Okay, the middle term's denominator is difference of squares. It's z squared minus 9. That's z plus 3, z minus 3. Can you find the common factor right now? Or the common denominator right now? George?
No. Well, actually, yeah.
Yeah and no. It's kind of a weird one, right?
Yeah,
Explain, George.
3 minus z is like really weird, so I guess you could just put 3 minus z under all of the ones where it's not there, and then you put z plus 3, z minus 3.
That's going to give us 3 binomials for everything, right?
Yeah.
That's really messy. So I don't want to do that. So try to think outside what else we can do. You want to help him? What do you think?
Could you factor out -1 and then, yeah.
What's 3 minus z? Isn't it really just z minus 3 if you factor out a -1? I showed you that trick in the middle of the year. If something is the order of the operation that's switched for what you want for subtraction, you could recreate it. So watch what I'm going to do. Make this z minus 3 here instead and put a -1 out in front. See what I'm doing? Why did I do that? Because now the denominators will only have 2 factors for the LCD. The LCD will only be z plus 3, z minus 3. If I had 3 minus z as a third factor, it'd just get messy, right?
Yeah.
Now, see the -1 that looks really annoying? Just move it up top. A negative in the denominator could be a negative in the numerator, can't it? So what is the numerator really?
-2 minus 3.
Yep, and then cross off the -1. See what I'm doing? Okay, I got rid of the numerator, made a negative z minus 3, inherently just putting the -1 up top and distributing it up top. Again, I'm taking the -1 that was in the bottom, moving it up top and distributing it to z plus 3, becoming negative z minus 3. So this -1 here goes right here, gets distributed.
So would that be -1 if you cancel everything?
So at this point we have, let me just rewrite it so it looks nicer, right? So that's what we have up top, and that's what we have in the bottom. Okay, so our common denominator is now there. We don't have to go really much further. Is there a way to copy and paste in this app? I wonder. There's got to be. Can I? No? Where's a copy's here, right? But I need to select something? How do I select something? Whatever, I'm wasting time, I think. Select, come on. No way to select. Oh, that's how it works. Whatever. So carry this whole thing down. Now, the LCD is z plus 3, z minus 3. So that needs to get multiplied by everything. By everything. It's difficult to write all of this and annoying. So try to pick up on trends. Let's just look at the first fraction only, please, okay? So I'm going to put a big plus sign here and leave a space. And then we have the second fraction and then equals over here. That'll go on the very end. 1 minus 5z over z plus 3. And the second one's going to go right in there. So, looking at the first fraction, if I multiply everything by the LCD in this equation, it simply means put the LCD up top. That's what the first term would look like. What's going to cancel automatically? What cancels? Yeah, z minus 3 cancels. Well, do the same thing for the next one. What's going to cancel in the next part? If I go look here, please look right here. If I put z plus 3, z minus 3 on the top, what's going to cancel?
Z plus 3, Z minus
The whole thing, right? Again, remember, I'm multiplying everything by z plus 3, z minus 3. That's my LCD. These are going to all cancel, leaving me with 11z plus 3 here. And then the last term, can I erase this? No, of course not. And then the last term I need to multiply again by z plus 3, z minus 3. Z plus 3 is going to cancel over here. So the first term just becomes negative z minus 3, and we're left with z plus 3. The second one is 11z plus 3. And on the right side we have, it looks like, oh, this is really messy. This is really z minus 3. I need an eraser to work on this thing. There we go. This will be z minus 3, and then 1 minus 5z. So this is the method number 2, where you find the LCD and multiply everything by that LCD. So look, here I multiplied by it. I didn't want to write this down again, so I multiplied it by it. Here for this one goes up, here it goes there, and then here is the third part where it's multiplied by for the third one. Why is this useful? What does it do to the equation? What kind of equation does it become? Okay? A quadratic. And we can solve quadratics. Now, look at the original problem back in the beginning. Tell me what domain restrictions I need to think about first. What can z not equal? George?
Negative 3.
Negative 3. Annette?
Z can't equal 0.
Z could equal 0 here. Be careful. I thought you had your hand up. Sorry, that's why I called on you. Max? 3. Let's look at your denominators. What would cause the denominator to become 0?
So
3 or negative 3. The denominator itself cannot be 0, but z could be 0. Because look 0 for z. Does it make the denominator 0?
No.
No. Yeah. So 0 could work for z, but the denominator cannot be 0. So you need to say, if I plug in a 3 here, doesn't that make that a 0? So it can't be 3. If I plug in a negative 3 here, it makes that 0, right?
Yeah.
So it can't be negative 3. What does this factor into? Z plus 3, z minus 3. So what are these restrictions? Well, they're the same thing that are already up there.
But if
This,
you
here,
had
this,
3
here.
and you only plugged in 3 for one of them, but
Doesn't matter. If any of the denominators are 0, you can't have a true equation. So these are called our domain restrictions. Write that down if you didn't know that. If you know it, you have to write it down. Domain restrictions. Because at the end of this problem, when we get answers, if we get those as an answer, what do we have to do to that answer?
cross out.
Good. Reject the solution. Reject. You've been rejected. All right, multiplying this out. Let's see what we got. I'm going to get negative z squared minus 6z plus 9. And be careful with this. This is a little bit messy. Minus 9. Minus 9. In the middle, I'm going to still have the 11z plus 3. And then on the end over here, it's a little bit messy also. We're going to end up with, if we multiply this all out and do a little bit of simplification, this is a z here. Make sure you know. Notice when I'm putting for my z's, I put a horizontal line because z's look like 2's. Okay, so I put that little slash. This is going to become negative 5z squared plus 16z minus 3. Okay, if you don't believe me, FOIL it out and check. We're at the point of the year where I'm not going to be going over how to FOIL, right? We know how to do that, so I have to assume that you can do this for now. So even if you didn't do it, just write it down for now, at least you have the next line. At this point, it's a quadratic. We move everything to one side and solve. I would move everything to the left-hand side so that it makes my leading coefficient positive. So I'm going to add 5z squared. I'm going to subtract 16z and add 3 to both sides. So on the left-hand side, I've got negative z squared, and 5z squared is going to be 4z squared. Follow me, please. I've then got, oops, let me move this up a little bit. I've then got, after that, negative 6z and 11z. What does that give me? 5z, and then take away 16z from that.
Negative 11z.
Very good. Last but not least, we've got negative 9 and 3 gives me negative 6, and then add 3 to that. Negative 3. Okay, let me check. Yes, I had the exact same thing. This can be factored, it turns out. Anybody have the factors for this? You know it's got to be 3 and 1 for that, for sure. That's a guarantee, right? Well, we don't know if it's 2 and 2 or 1 and 4 for z, right? I'll give you the factors for the sake of time. It's 4z plus 1 and z minus 3. Now, please, guys, don't ever think, oh, he's not even factoring. I guess we have to know to do this. What do you do if you can't factor this? Come on.
Quadratic.
Go right to the quadratic. Very good. Go right to the quadratic. So our answers are what? Our answers are what? Temporarily. Our answers are what right now? Annette?
Negative 1/4 and 3.
And realistically, what answer do we have to reject?
Negative 4.
No,
Three.
because it can't be because we're making 0.
Good. The domain restriction said we couldn't have 3. So our answer is indeed negative 1/4. Questions on this? Is the approach reasonable? Is it similar to yesterday? The idea of finding an LCD and multiplying everything by that LCD. Now, I also show the other method in the notes. So there's 2 methods all written out in the notes. So if you want to see the other method where you make all the denominators the same, and then you just cross off all the denominators, that's method 1 in the notes. What we just did was method number 2. Okay? Is that clear? Questions? This is not an easy topic. The next problems are going to get harder. That's what I'm asking. Okay. Try and spend, what do we got? Anyone know the bells? Want to check on an E-day-ish? What period 4 would be?
On E-Day, period 4.
You have it?
E-Day? Yeah, 11:57.
Okay. So it's probably going to be like 11:53 or something because of the exam and stuff. So let's quickly think about this. I'll give you 1 minute maybe. 1-2 minutes with the person next to you. Try to come up with something here. It helps with a let statement.
What? How's that possible? Wait, right. Wait, but why is it dots?
Yeah, it's weird. I don't know what that is. I noticed it the other day. If you use your iPad pencil on someone else's, it comes up as like weird. It only works sometimes. It's really arbitrary. I have no idea.
Oh my god!
It's like showing little dots. And don't get sidetracked, guys. Come on. It's not. It's weird.
Do it again.
It won't work anymore.
Look, sit down. Bridge, sit down. Come on. Sit down, guys.
Alright.
Now I have to get
I'm using these as my let statements here, guys. You don't have to use the exact same ones, but your equation is going to look different. Oh, it's not up. Hold on. These as my let statements because I think of this problem as the gun that can provide more spray paint will take less time. So I'm calling that T. The weaker gun or the smaller gun would take longer, so I'm calling that T plus 4. It's just logical to start that way. Okay, I recommend doing it that way.
I'm just copying down what you were.
Oh, it's actually not. So, yeah, that's fine. Yeah. So, the signal's far out. Go.
I find this problem harder than the next one, by
I'm
the way.
confused.
Yeah,
Are
me
they
too.
saying that together they can at the same time when they're spraying?
So it's T times T.
Would you?
I'm going to give you a hint. Remember yesterday I gave you the hint with the writing, with English there? Okay. So let's say,
So x equals.
fraction of wall painted by larger gun plus, here's your equation, the fraction of the wall painted by the smaller gun should equal what?
14.
No, fraction.
Equals 1.
Thank you. How many walls are they going to paint?
1.
So if you paint a third of the wall and she paints 2/3, what do they add up to? 1. So that's the equation you want to use. Okay? It's tough to determine what goes in those spots, though. Let me give you a little, maybe hint. It says here that it's going to take 14 hours total, right? 14 hours total. T is the number of hours it would take the larger gun on its own to paint the wall. T plus 4 is the amount of time it would take the smaller gun alone to paint the wall.
Yeah.
Together, though, if they paint, they could add up to make the entire wall. Now, you got an idea?
Well, yeah, I was just asking, like, do you get like a 1 decimal?
You might get like something repeated. I don't even know. I don't care about that. I'm asking about the equation, guys, not the answer. What's your equation? Give me your equation.
It's 14 over x plus 14 over x minus 4 equals 1.
Where'd you get that from? You're exactly right. Who came up with that? Where'd you come up with it from, honestly? Because if I saw this problem as a student, I would have no idea to come up with that equation.
Well, we just went like x.
Listen to George. This is right. I used x plus 4 instead, but same thing.
So, we're just like, it equals 14 hours to paint 1 wall. So, if you divide it by the amount of hours each one does and you add them together, it would equal 1.
Yeah, it's not really the right explanation.
So for each one, like, it's like before the
Give an example if you want, yeah.
right, so for the second one, we set that as x. So in 1 hour, it's going to do like 1 over x, not 4. Then since there's 14 hours in all, it's going to do 14 hours, so it's going to be 14 over x. And for the other one, it's going to be 14 over x minus 4. And if you add them together, it's going to be 1.
So if you think about this for a quick second, right? How long does it take the larger gun to do it by itself? Let's say it takes 25 hours, okay, the larger gun by itself. 14 out of 25 would give you the fraction of the wall painted in 14 hours by that gun. If it literally takes me 25 hours to do this by myself, but when I'm working with someone else, I only have to do 14 hours worth, I'm doing 14 25ths of what I would have done. So in reality, you're going to end up with exactly what they said. 14 over t plus, I did it with t plus 4, plus 14 over t plus 4 equals 1. You could have done it either way. Either way works. Okay? So tonight, here's what you guys want to be thinking about. The last example is about a boat traveling with distance rate. Absolutely get to that. We can maybe ask questions on this tomorrow. Tomorrow's your review, right? So we can go over this tomorrow. We can go over stuff from the last one with the mixing problems also if you want. But if you want to see me individually on any of this stuff, please come by during free when I'm free also.